So today we are going to discuss about trigonometric identities problem, which is suitable for class 10. So we have already written 5 questions in the whiteboard and we are going to solve step by step. So question number 1. The given information is sine square alpha plus sine to the power 4 alpha is equal to 1. So from this equation we can write sine to the power 4 alpha is equal to 1 minus sine square alpha. That implies sine to the power 4 alpha is equal to cos square alpha. So we get the value of sine to the power 4 alpha as cos square alpha. Now we have to prove a relation that 10 to the power 4 alpha minus 10 square alpha is equal to 1. So start from left hand side. 10 to the power 4 alpha minus 10 square alpha. So 10 to the power 4 alpha can be written as sine to the power 4 alpha divided by cos to the power 4 alpha minus 10 square alpha. Now we have already got the value of sine to the power 4 alpha as cos square alpha. Substitute that value. So the next step is cos square alpha divided by cos to the power 4 alpha minus 10 square alpha. So cancel cos square alpha from numerator and denominator. We are getting 1 by cos square alpha, which is sec square alpha minus 10 square alpha, and this is a standard identity. That value of sec square alpha minus 10 square alpha is 1, hence proved. So the main technique to solve the first question is to express sine to the power 4 alpha in terms of cos alpha. Then start from left hand side, substitute the value, calculate and use suitable identity to get our required result. Now we are going to solve our next question, that means question number 2. What is given in the question? Cos theta plus sin theta is equal to root 2 cos theta. So from this we can write sin theta is equal to root 2 minus 1 multiplied by cos theta. So what will be the value of cos theta? Sin theta divided by root 2 minus 1. Since we get root in the denominator, we have to do rationalization. So multiply numerator and denominator by root 2 plus 1. We are getting this. So root 2 plus 1 multiplied by sin theta divided by root 2 plus 1 into root 2 minus 1. This is of the format a plus b into a minus b. So a square minus b square. The denominator becomes 1. So value of cos theta is root 2 plus 1 into sin theta. Now we have to prove a relation that cos theta minus sin theta is equal to root 2 sin theta. So start from left hand side, cos theta minus sin theta. Substitute the value of cos theta here, root 2 plus 1 into sin theta minus sin theta. Now sin theta is common from these two terms, and we get root 2 plus 1 minus 1 within bracket, 1 cancelled. So the answer is root 2 sin theta, which is the right hand side of the required relation. Hence, we have proved the relation using some calculation. So next, we are going to solve our next question. Question number 3. The given value is sec theta plus tan theta is equal to 2 plus root 5, and we have to find the value of sin theta and prove that value of sin theta is 2 by root 5. So how we can solve this type of question? Since we are given sec theta plus tan theta and there is a standard identity involving sec theta and tan theta, so start from that. Sec square theta minus tan square theta is equal to 1. The standard identity is that the value of sec square theta minus tan square theta is 1. So we can use the formula of a square minus b square in the left hand side. Sec theta plus tan theta multiplied by sec theta minus tan theta equals to 1. Substituting the given value, we can say the value of sec theta minus tan theta is 1 by 2 plus root 5. Now do some kind of rationalization. So we are multiplying the numerator and denominator by root 5 minus 2. So sec theta minus tan theta is equal to root 5 minus 2 divided by root 5 square minus 2 square. That means sec theta minus tan theta is equal to root 5 minus 2 as the denominator becomes 1. So our given equation was sec theta plus tan theta equals to 2 plus root 5, and our obtained value is sec theta minus tan theta is root 5 minus 2. Now solve these equations by method of elimination. Adding these equations, we are getting 2 sec theta is equal to 2 root 5, 2 cancelled. So sec theta is equal to root 5. That implies cos theta is equal to 1 by root 5. Now we know that sin theta can be written as root over 1 minus cos square theta, standard identity, root over 1 minus 1 by 5, root over 4 by 5, and the required value is 2 over root 5. So we have proved the value of sin theta is 2 by root 5 here by using identity and some solution of equation. Now we are going to solve our fourth question. In this case, we are given a trigonometric equation 4 root 3 cos square theta minus 4 sin theta plus root 3 equals to 0. We have to solve this trigonometric equation. That means we have to find all possible values of theta which can satisfy this given equation, where a restriction is given that theta lies between 0 to 90 degree. That means theta is an acute angle. So how we can solve this type of trigonometric equation? Our main target is to convert this equation into such an equation where we have only one trigonometric function. In this equation, we have cos theta and sin theta. That means two trigonometric equation. But we have to convert it into some equation where we have only one of them. So now using some standard trigonometric identity, we can write cos square theta is 1 minus sin square theta. So we are changing the equation where we have only sin theta. The remaining terms are minus 4 sin theta plus root 3. Now open the bracket. 4 root 3 minus 4 root 3 sin square theta minus 4 sin theta plus root 3 equals to 0. So the equation reduces to 4 root 3 sin square theta plus 4 sin theta minus 5 root 3 equals to 0. So now we can do middle term factorization. Product of 4 root 3, that means coefficient of leading term, and constant term 5 root 3 is 60, and the difference of is 4. So we are breaking the middle term 4 sin theta like this. 10 sin theta minus 6 sin theta. From first two terms, we can see clearly that 2 sin theta is common. So within bracket we get 2 root 3 sin theta plus 5 from third and fourth term minus root 3 is common, and within bracket we are getting 2 root 3 sin theta plus 5 equals to 0. So we get the complete factorization is 2 root 3 sin theta plus 5 multiplied by 2 sin theta minus root 3 is equal to 0. So product of two factors is 0. That means either first one is 0 or second one. So 2 root 3 sin theta plus 5 equals to 0, or 2 sin theta minus root 3 equals to 0. From the first equation we get the value of sin theta as minus 5 by 2 root 3, which is impossible as it is given that theta lies between 0 degree and 90 degree. So value of sin theta is always positive. So this negative value of sin theta is completely invalid. So we are going to our second equation. Sin theta is equal to root 3 by 2. So it is clear from that the value of theta is 60 degree. So what is the required solution of the given equation? That is theta is equal to 60 degree. That means the acute angle 60 degrees satisfies the given trigonometric equation. So now we are going to solve our last question in this list. We are given a standard trigonometric identity. What we have to remember? Sin A plus B is equal to sin A into cos B plus cos A into sin B, and we have to find the value of sin 120 degree using that identity. How to solve this type of question? From trigonometric table, we know the value of standard angles. That means sin 0 degree is 0, sin 30 degree is half, sin 45 is 1 by root 2, sin 60 is root 3 by 2, and sin 90 is 1. So we have to remember that table. So now we should choose A and B in such a way that they are standard angles as well as their sum is 120 degree. So clearly we can choose A is equal to B is equal to 60 degree, because 60 degree is a standard angle and A plus B will be 120 degree if we choose both of them as 60 degree. Now substitute the values in the given identity. So sin A is 60 degree plus B is 60 degree is equal to sin 60 into cos 60 plus cos 60 into sin 60. So the left hand side becomes sin 120 degree. Now put the values in the right hand side. Value of sin 60 is root 3 by 2. Value of cos 60 is 1 by 2. Similarly, cos 60 is half. Sin 60 is root 3 by 2. So root 3 by 4 plus root 3 by 4, which is equal to 2 root 3 by 4. Hence, value of sin 120 degree is equal to root 3 by 2. This is our final answer. So using some identity, if we want to find the value of some trigonometric ratio, we have to choose the angles in such a way that the angles are standard angles and their sum or difference giving the required angle.